Okie dokie. In this problem, we are given the function y of x with multiple layers, and of course we are finding the derivative using chain rule. Lots of practice in this quiz. This is the main focus, so let's jump right into it. Our innermost layer is the one with x. So x, I guess we could call our inside layer, but we probably want to start outside of that. So x just has a derivative of 1, so we don't need to worry about that. We more need to worry about what is outside of the x layer, I guess. So negative cosine of x should be our innermost layer. As we work our way out, we have 2 raised to the something, and then the natural log as our outermost layer. So starting with our outermost layer, the natural log has a derivative. Natural log of something has a derivative of 1 over that same something. So we should have 1 over 2 to the negative cosine of x. That is the derivative of the natural log piece. So as we work our way in, we have 2 raised to the something first. The derivative of a number to the exponent should have that same exact number to the exponent in its derivative. And then we just need to multiply by ln of the base number. And that's it for that middle layer. Keep in mind this is corresponding to the derivative of 2 to the x, the exponential derivative, which looks like this. Alright, so then one last layer, and that is of the negative cosine of x. Negative cosine of x has a derivative, well, let's think of just the derivative of cosine of x. Cosine of x has a derivative of negative sine of x. And so negative cosine of x has a derivative of negative sine of x, which becomes positive sine of x. And so I don't know if that was, too much and too whatever, but negative cosine of x has a derivative of positive sine of x. That's the takeaway. We are looking for all of these terms here. I'm looking for, let's start with sine of x. Which ones don't have sine of x? D, C, and I think that's it. So then, really sine of x should be on the outside, like this, rather than up in some exponent. So naturally, I want to eliminate option A, but B looks very minimal. However, it might actually be the case. What terms do we see in B that we have in ours? We see ln of 2. ln of 2, we see the sine of x. We see the sine of x, which means somehow the rest of it should have canceled out. Would this make sense? Well, we have 2 to the negative cosine of x times 1 over 2 to the negative cosine of x. It's basically like having a 1/2. It's basically like having a 1/2 multiplied by 2. We have the number on top canceling with the number on the bottom. And all we're left with is ln of 2 times sine of x. And so this is a great example of, even if we didn't, understand why these canceled out, if we just used process of elimination to find which answers had sine of x correctly, just like out and about and not in the exponent place, then we want to stick with those hard facts. We want to eliminate any that we know for sure cannot be right based on what we have, and then maybe make sense of it after the fact. All right, let's go ahead and do, I think, 2 more examples. So in this one, we have the innermost piece is this s. So the derivative of s is just 1, so we kind of take a step outside of that, and really the innermost piece is the square root of s. Then we have the 3 raised to the something. Then we have the ln. So in this case, we want to find p prime of s. Derivative of natural log of something is 1 over that something. So we keep the 3 to the square root of s the same when we throw it in the denominator. Then, just like the last one, derivative of 3 to the something, a number to the something, is that same exact term times the ln of the base number, ln of 3. And then we just have the derivative of the square root of s left. Square root of s, we might have talked about it in the last section, can be rewritten as s to the 1/2. When we take the derivative of s to the 1/2, we get 1/2 times s, and from the exponent. 1/2 minus 1 is negative 1/2. You might remember our trick that was when we have to take a fraction and subtract it by 1, we take the top number minus the bottom number. 1 minus 2 is negative 1, and then we just leave it over 2. So what we have here is 1/2. Actually, what I might do, let's go ahead and rewrite this first without any negative exponents. So if we rewrite the derivative of the square root of s without negative exponents, s to the negative 1/2 is the same as throwing that term on the bottom with a positive exponent, so s to the 1/2. And then s to the 1/2, again, is equivalent to the square root of s. So really what I'll plug in is 1 over 2 times square root of s. This is our final derivative of this piece. Excuse me. All right. So let's see what we can find. Just like in the last one, we see these terms, 1 over something times that something, being multiplied, so those terms will definitely cancel. So we're looking for an ln of 3 and just times 1 over 2 squared of s. If we take ln of 3 times 1 over 2 squared of s, it's basically like ln of 3 over 1 times this fraction. So multiplying across the top would give us ln of 3 over 2 square root of s. In other words, option D. All right, let's go ahead and do one more example. Our innermost layer is the one with the variable, and so not just z, but the next outer piece is ln of z. So ln of z is our innermost layer. What's outside of the ln? A big square root. And then outside of all of that is the e term. Our derivative of any function that starts with e to the something, keep in mind, we should have this same exact e term in our answer. We can eliminate any that don't have this same exact e term as we originally had. So that narrows down the options just a little bit. So we know we want the e term, e to the square root of ln of z. Then we want the derivative of the square root of something. Keep in mind, we just found the square root of something has a derivative of 1 over 2 square root of s. So if we have, in other words, square root of x, that will always have a derivative of 1 over 2 square root of x. Personally, I think it's a good one to have memorized so you don't have to deal with all the fraction stuff. But again, using all the fraction stuff is why it worked out. So square root of x has a derivative of this, 1 over 2 square root of x, which means square root of ln of z will have the same exact derivative, except with ln of z plugged in place of x. So the derivative of our middle layer is this, 1 over 2 times the square root of ln of z. Then the very last layer, so that was for the ln of z, and then our innermost layer is the ln of z. So ln of z has a derivative of just 1 over z. So we are looking for all these terms in our answer. Okay, so I would say in layman's terms, these ones have fractions and a does not have a fraction. And nothing is canceling out in these fractions. So a is likely off the table. And then what's the only difference between c and d? Well, c doesn't have this z that d has. And should we have a z in a denominator? Well, we have a 2 here, which they both have. We have the square root, which they both have. But then this z in the denominator should play a role. It should be incorporated in the mix. And so it looks like D is our best answer. I hope these worked out examples help. I hope you can use something from them. Again, I don't have every single example you might see worked out, but hopefully you can apply these ideas to the problems that you see. If you have any questions, please let me know.